Dmitri Mendeleev, the man who organized the elements. In the winter of 1869, a Russian chemist sat alone at his desk, surrounded by pieces of paper. The room was quiet. Outside, St. Petersburg was cold and gray. Inside, Dmitri Mendeleev was thinking about something that had confused scientists for years. The elements. Hydrogen, oxygen, carbon, iron, gold. Dozens of substances, each with different properties. Scientists knew many of them, but nobody had found a clear way to organize them. Mendeleev had been trying for days. He wrote the names of elements on small cards. Then he moved them around. He compared their atomic weights. He studied their chemical properties. He looked for patterns. Again and again, the patterns seemed to disappear. Then, slowly, something changed. Mendeleev began to see order inside the chaos. And what happened next would change chemistry forever. But the story did not begin in that quiet room. It began many years earlier, thousands of kilometers away, in Siberia. Dmitri Ivanovich Mendeleev was born in 1834 in Tobolsk, a small town in the Russian Empire. He came from a large family. His father was a teacher, but his eyesight became poor and he eventually lost his position. Life became difficult. Mendeleev's mother worked hard to support the family. She understood that education could give her children a better future. She encouraged Dmitri to study and learn. As a boy, Mendeleev was curious about almost everything. He was not simply interested in memorizing facts. He wanted to understand how things worked. That habit would stay with him for the rest of his life. When Mendeleev was still young, his family moved west. His mother made a huge sacrifice to help him continue his education. She took him on a long journey to St. Petersburg, where he could attend a good school. The journey was difficult. But his mother believed his future was worth the effort. In St. Petersburg, Mendeleev studied science and mathematics. He soon showed that he had a powerful mind. He was especially interested in chemistry. Chemistry was changing quickly during the 19th century. Scientists were discovering new elements and learning that matter was not as simple as it appeared. But there was a problem. Nobody knew exactly how all the elements were connected. Imagine having a box filled with dozens of different keys. Each key looks different. Some are large. Some are small. Some seem similar. But you do not know which keys belong together. That was chemistry. Scientists knew the elements existed, but they did not have the full picture. Mendeleev wanted to find it. After completing his education, he began teaching and researching chemistry. He traveled to Europe and spent time studying with leading scientists. He worked hard. He wrote books. He studied chemical properties. He experimented in laboratories. And he became convinced that there had to be a deeper order among the elements. At the time, scientists had already noticed certain patterns. Some elements behaved in similar ways. Others had similar chemical properties. There had also been attempts to arrange the elements by their atomic weights. But the systems were incomplete. Some worked for a few elements and then failed. Mendeleev thought the problem was not that the elements were disorganized. The problem was that scientists had not yet found the right way to look at them. In 1867, Mendeleev became a professor at the University of St. Petersburg. He began preparing a textbook for his students called The Principles of Chemistry. Writing the book forced him to think carefully about how chemistry should be taught. He needed to explain dozens of elements and their relationships. But as he tried to arrange them, he faced the same problem that had troubled other scientists. Where should each element go? Mendeleev began making cards. On each card, he wrote information about an element. Its name. Its atomic weight. Its properties. He treated the cards almost like pieces of a puzzle. He moved them. He compared them. He rearranged them. He searched for a pattern. The work became almost obsessive. Then, in early 1869, Mendeleev began to see something remarkable. When the elements were arranged in order of increasing atomic weight, similar chemical properties appeared at regular intervals. There was a repeating pattern. It was not perfect. Some elements did not seem to fit. But Mendeleev believed the pattern was real. And then he made a bold decision. He left gaps. This was one of the most important parts of his discovery. Other scientists might have assumed that a gap meant the system was wrong. Mendeleev thought differently. He believed that some elements had simply not been discovered yet. If the pattern was correct, those missing elements should exist somewhere in nature. And he went even further. He predicted what those elements would be like. He estimated their atomic weights. He predicted their densities. He predicted how they would react with other substances. He even gave temporary names to some of them. One was EKA aluminium. Another was EKA silicon. It sounded strange. How could someone predict an element that nobody had ever seen? But Mendeleev trusted the pattern. His periodic table was not simply a list of known elements. It was a map of what remained to be discovered. That was the idea that made his work so powerful. And then came the test. In 1875, French chemist Paul-Émile Lecoq de Bois-Baudran discovered a new element. It was later named gallium. Its properties were remarkably close to what Mendeleev had predicted for EKA aluminium. Mendeleev's prediction was right. A few years later, another missing element was discovered. It was germanium. Again, its properties closely matched Mendeleev's prediction for EKA silicon. The scientific world began to pay attention. His table was no longer just an interesting idea. It was working. Scientists could use it to understand relationships between elements and to predict new discoveries. But Mendeleev's life was not only about the periodic table. He was a restless scientist. He studied solutions, gases, petroleum, agriculture, industry, and many other subjects. He believed science should be useful. He traveled across Russia and observed industrial processes. He became interested in oil and petroleum production. He studied how Russia could improve its industries and use its natural resources more effectively. He also became involved in public debates about science and education. Mendeleev was not afraid to disagree with other people. He could be stubborn. He could be difficult. But he believed strongly in his ideas. His personality sometimes created problems. He had disagreements with university officials and government authorities. Eventually, his relationship with the University of St. Petersburg became strained, and he left his teaching position in 1890. But leaving the university did not stop him. He continued working. By then, the periodic table had become increasingly important. And there was another major reason for its success. Mendeleev had not simply arranged elements based on numbers. He had focused strongly on their properties. When atomic weights created problems, he was willing to question the accepted data. He even changed the position of some elements because their chemical behavior suggested they belonged somewhere else. At the time, this was controversial. Today, we know why. The modern periodic table is arranged by atomic number, not atomic weight. The reason is that the atomic number, the number of protons in an atom, defines the element. Mendeleev did not know about protons. The atomic structure of matter was still largely unknown. But his table was close enough to reveal the deeper pattern. It was as if he had found the outline of a building before anyone knew what was inside it. Then science moved forward. The electron was discovered. Atomic structure became clearer. The nucleus was discovered. The idea of atomic number emerged. And the periodic table became even more powerful. Mendeleev's original arrangement was modified, but its central idea survived. Elements belong to families. Their properties repeat in patterns. The table can help us understand what an element will do before we study it directly. That simple idea became one of the foundations of modern chemistry. But Mendeleev's story was also a story of uncertainty. He lived at a time when science was changing rapidly. Old ideas were disappearing. New discoveries were arriving almost every year. The atom itself was still a mystery. Scientists did not yet understand electrons, protons, or quantum mechanics. Yet Mendeleev had the courage to search for order when much of the evidence was incomplete. That is what makes his story so interesting. He did not wait until every answer was available. He worked with what he had. He looked for patterns. And when the evidence suggested that something was missing, he was willing to say, "Perhaps we have not discovered it yet." That idea changed the way scientists thought about discovery. Sometimes the most important thing is not what you can see. It is what the pattern tells you should be there. Mendeleev continued working into old age. His health eventually declined, but his curiosity did not disappear. He remained interested in science, industry, education, and the future of Russia. He received international recognition for his work. Scientists around the world knew his name. But he did not receive the Nobel Prize in Chemistry, despite being one of the most important chemists of his generation. Mendeleev died in St. Petersburg in 1907. He was 72 years old. By then, the periodic table had become part of scientific language. But the full importance of his work would become even clearer after his death. Today, every chemistry student encounters the periodic table. It sits on classroom walls. It appears in textbooks. It is built into laboratory software. It guides researchers searching for new materials. It helps scientists understand chemical reactions, metals, gases, medicines, electronics, energy, and countless other parts of modern life. The table has grown far beyond Mendeleev's original version. New elements have been discovered. Some have been created artificially. The number of known elements has increased dramatically. But the basic structure remains. Groups, periods, families, patterns, order. A map created from a collection of small cards became one of the most recognizable symbols of science. And perhaps the most remarkable part is that Mendeleev did not know everything about the world he was organizing. He did not know about the proton. He did not know about the neutron. He did not know about the electron when he first created his table. He knew nothing about quantum mechanics. He could not see inside the atom. Yet he found a way to organize the behavior of matter. His achievement reminds us that scientific progress does not always begin with complete knowledge. Sometimes it begins with a question. Sometimes it begins with a strange pattern. And sometimes it begins with a person who refuses to accept that a problem is impossible. Picture Mendeleev again in that cold room in St. Petersburg. Papers are spread across his desk. Names of elements cover the cards. He moves one. Then another. He studies the pattern. There are gaps. But instead of seeing failure, he sees possibility. Somewhere, he thinks, the missing elements must exist. Years later, nature proves him right. That is the moment that defines his legacy. Dmitri Mendeleev did not discover every element. He did something different. He showed that the elements were not a random collection of substances. They followed a pattern. And once that pattern became visible, chemistry changed forever. From the metals in our buildings to the silicon in our computers, from oxygen in our lungs to the elements inside distant stars, the same periodic order helps us understand the material world. A young man from Siberia had once traveled across Russia because his mother believed education could change his future. Years later, that young student changed the way humanity understood matter. He took a world that looked chaotic and found an order inside it. and on a simple table of elements, he left scientists something more valuable than an answer. He left them a way to ask better questions. The next time you see the periodic table, look beyond the boxes and symbols. Behind it is a story of a man sitting at a desk, moving pieces of paper, searching for a pattern that nobody else could fully see. His name was Dmitri Mendeleev. And he organized the elements.